Our next speaker is Professor Kelsey Johnson. Kelsey Johnson is an Associate Professor of Astronomy at the University of Virginia, adjunct faculty at the National Radio Astronomy Observatory, and the founder and director of the Dark Skies Bright Kids Outreach Program. She received her Ph.D. from the University of Colorado in 2001, where she held a NASA Graduate Research Fellowship and was awarded the Dorothy Martin Woman Doctoral Student Award, awarded annually to top female graduate students in each discipline. After earning her doctorate, Johnson held a National Science Foundation Fellowship followed by a Hubble Fellowship. She has received a National Science Foundation Career Award, a Packard Foundation Fellowship, a Distinguished Foundation Career Award, a Packard Foundation Fellowship, a Distinguished Investigator Fest Award, and an Excellence in Diversity Award. She is a member of the International Alma Science Advisory Committee, for which she is both a former chair and current vice chair. Her research is focused on star formation throughout the universe, and in particular the impact of different physical environments. Professor Johnson.
Good evening. I want to start by saying, with a nod of deference to my colleagues, that I think I have the best job in the world. I actually get paid to think about the universe, and of course work with some of the most brilliant young minds in the country, which is fantastic. Now, one of the things that comes with my line of work is that when I meet someone new, and you start with that small talk, chit chat, the conversation usually comes pretty quickly to, oh, what do you do? And I always debate how to answer that question. There are a number of ways I could answer it, as with, I'm sure, many of you. But what I think in my head is, if I don't want to talk to this person anymore, there's one thing I can say that will end the conversation right there, and that is astrophysicist. If I say astrophysicist, I usually get one of two responses. The first response, about 50% of the people will give me, is that, oh, I failed my class. I failed my physics class. And I think, well, statistically speaking, that's not actually likely. The second thing that I often hear is, well, what do you do? Don't we already kind of know everything there is to know about the universe? I mean, how many constellations are there? And so my hope is that over the next 10 minutes, to give you a sense that we really have only scratched the surface and that our knowledge of the universe is exceptionally shallow. So the image I'm showing you right now, Skylar, if you could get the lights for me. This is just what has to happen in an astronomy talk, I'm sorry. The image I'm showing you here is, to my mind, one of the most remarkable images of the universe we've ever obtained. This image is known as the Hubble Ultra Deep Field. Now, there are a couple stars in this image, which you can tell because they have these pointy things on them. They're called diffraction spikes, and I don't want you to leave thinking that stars have spikes, because they don't. But everything else in this image is a galaxy containing billions of stars. In fact, even the teeniest, tiniest, smudgiest smudges in this image that you can barely see are galaxies. In fact, it's these teeniest, tiniest, smudgiest smudges that you can see, you can barely make out in this image, that you're getting light from now, that left those galaxies 13 billion years ago. You're seeing back in time to almost when the universe was formed, which I think is absolutely remarkable. Now, astronomers, or astrophysicists, if I don't want to talk to you anymore, like me, you can do the lights again, thanks guys. We see images like this all the time. I think we tend to get a little bit desensitized to them. Those weren't my notes, so I'm not going to worry about that. Let me bring this back down to Earth, though, because it's hard to get a sense of perspective. So I have my favorite demo here that I think some of you have seen before, but I have here, I hope some of you can see it in the back, a grapefruit. It's an average grapefruit. I just bought them at Harris Teeter before I came in, so they're fresh. I want you to envision for a moment that this is the sun. Now, if this is the sun, I want you to think, okay, if that's the sun, how big is the Earth? Just envision it in your mind's eye. And the answer is one of these. So I'll take out a few, and I'll hold one up. These are little nonpareil sprinkles. Okay, can you see this in the back? This is how big the Earth is relative to the sun. You could fit 1 million Earths inside the sun if you were so inclined and you didn't care about dying or anything like that. Now, the next question I want you to think about in your mind's eye is, if this is the sun and this is the Earth, how far away from each other should they be? You have to answer. And we're gonna see if I can avoid hurting anyone here. So I'm gonna just put the Earth up here on the podium where everyone can see it. Okay, so you're not on the football team. That's about right. It's about 15 meters. So I want you to just think about this for a second. Here we are on this sprinkle, and there's our sun. Nice job, she even held it up, brilliant. Okay, now let's take this one step further out. Let's talk about the nearest star. So I have a second grapefruit here, or star. And I want you to think about for a second, where should this grapefruit star be? And I'll tell you that my arm is not nearly good enough for that. Not nearly good enough. In fact, if any of you are headed to the West Coast for spring break, you can take this with you. The nearest star on this scale is, let's say in LA or Seattle. And I want that to give you a deep, visceral sense for the scale of the universe. And not only are we trying to understand our planet and our solar system, which is only, to the front row, we're trying to understand not just the nearest star, which is in Seattle or LA, or even just our galaxy. We're trying to understand the entire universe. And so hopefully you can understand that there's really a heck of a lot we don't know. So what I want to do is share with you, given how much we don't know, my top 5 questions in astrophysics. Number 5. What are dark matter and dark energy? Now, you may not have heard these terms before if you haven't had an astrophysics class. Dark matter and dark energy, the word dark really here is just astronomy jargon for something we can't see. So we call these dark. Now, it turns out that we only know what 5% of the universe is made of. And only 5% of the universe is made of what I'll call normal matter. So your chair, this grapefruit, my podium. These are normal matter, and that's only 5% of the universe. The other 95% of the universe are these dark things. We know that they're there because we can see their effect on the universe around them, but we don't know what they are. Oops. Number 4. What happens inside black holes? Black holes are real, they exist. We know they're there because we can see their impact on things around them. We know that inside of their boundary, they warp space-time so extremely that not even light can escape. But where we get into real trouble is as we go deep down toward the center of these black holes, where things become infinitely small and infinitely dense, and we hit something we think, what will be a singularity. Singularities piss us off. They are not good in math, they're not good in philosophy. We think there's a singularity there. But the real problem is that as we get close to the singularity, the laws of physics as we know them literally break down. We have these two pillars of modern science. We have general relativity on one hand, and we have quantum mechanics on the other hand, and the two of them do not get along in this regime. Something's got to give. We don't know what it is. Number 3, is there other life in the universe? Billions of stars in our galaxy, billions of galaxies. The possibilities of other life in the universe almost seems to be overwhelming. But there's a lot we don't know about this. There's a lot we don't know about the biology. There's a lot we don't know, I dare say, about the sociology. And what I mean by that is we tend to project a lot of human characteristics onto extraterrestrial life that aren't necessarily valid. But one of the things that I worry about as an astrophysicist is, let's say life forms on another planet, and let's say it evolves, and let's say it gets some kind of intelligence, whether it's alien or not. How likely is it to survive its technological adolescence? And what I mean by that is there's this really scary, dangerous time where you're just technologically advanced enough to destroy yourselves, but you're not quite smart enough not to. And I would argue that we're actually in that state right now with our own civilization. Number 2, are there other dimensions? Now this seems pretty sci-fi, but there's real reason, based on real physical theories, that have some validity, though they've not been fully tested, to think there are other dimensions. Now we have 4 dimensions we commonly perceive, up, down, left, right, back, forth, and then there's time. So we have 4 dimensions that most people can commonly perceive, and if you happen to be a person who can perceive more than 4, please let me know after the talk because I have some recruiting to do. But some of these physical theories actually predict that there might be up to 26. And we can only perceive 22 of those. And this isn't in the realm of science fiction. These are real physical theories that we think might be valid. And number 1, my top question, which I know is many people's top question about the universe, is what caused the Big Bang? One of the reasons I love this question is it's in some sense the ultimate question. Now let's say I could tell you what caused the Big Bang, which I can't. There are a number of theories for what it might have been. But then what we find ourselves with is this causal chain of infinite regression. What caused the Big Bang, smarty pants? And we end up going down this loop and it isn't clear where it stops. And so we end up with a fundamental philosophical dilemma that's very hard to get around. But the reality is, we don't know what caused the Big Bang. And there are some very fun answers to that. Now, when we think about these questions, we think about how we might answer them. And our primary tool is our brain. And we can do a number of really interesting and phenomenal things with our brains. But the other problem that astrophysicists have is that the only information we can get from the universe, with the exception of a few things nearby in the solar system, is from light. Light is the only mechanism we have to learn anything about the universe. So astronomers are scavengers, and we've gotten very, very, very good at decoding every small nuance that light has to tell us from everywhere in the universe. And of course, to do this with light, we use telescopes or observatories. And before I close out, I want to show you 2 observatories that I think you here at UVA should be particularly excited and knowledgeable about. The first is the Green Bank Telescope. Some of you may have seen this before if you have ever gone skiing in West Virginia. The Green Bank Telescope is the largest steerable telescope on the planet. It is essentially a football field up on stilts, if you can envision that. It is in fact the largest permanent moving structure on the surface of the Earth. This telescope is remarkable. It's one of the most powerful instruments of its kind, but why I'm telling you about it is that it's only a few hours away. It's a national treasure. It's literally right in our backyards, and if you have a chance to go there, you absolutely should. The second telescope I want to show you is known as Alma. This is the Atacama Large Millimeter Array. It's currently being built in the Atacama Desert in Chile. This telescope is the most technologically advanced and therefore most expensive telescope ever on the planet. And it's brand new in a number of ways. It's absolutely phenomenal, and I could wax poetically about it for hours, but the reason I'm telling you this is because the North American headquarters for the biggest, baddest telescope ever on the planet are here on UVA grounds, right around the corner from the astronomy building, and this is a really, really big deal. So before I end, I want to show you what I think is perhaps the most remarkable image ever taken in astronomy. I started out by showing you the Hubble Ultra Deep Field, but I want to end with one that I think is equally remarkable, but for very, very different reasons. Sky, if I could have the lights. This is an image that was taken in the 1970s by the Voyager spacecraft. And I realize that was before most of you were born, but you're just going to have to deal with us old people for a little bit longer. This probably looks pretty old, pretty cruddy, pretty grainy, but the reason this is remarkable is that this is the most astounding photograph of Earth that has ever been taken. So Voyager was at the distance of Saturn, which all things considered is not actually that far away. And it turned around and it took a picture of Earth. Can you see it? Oh. Now I'm not showing you that because I want you to feel little. I'm showing you this because I want you to understand the magnitude and the vastness of the universe. And I want you to think about this picture from time to time as a testament to human ingenuity. The fact that we live on this teeny tiny sprinkle floating in the vastness of space, and we know anything about the universe, and we know to some extent what we don't know about the universe, is absolutely astounding. And like I said, it's a testament to human ingenuity, and it's a testament to human curiosity, and we've only just gotten started. Thank you.